So in today's video, we'll understand one of the most important topics in design verification, the basic test bench functionality. So to make it easier for beginners, and I have explained everything in a clear step by step. So by the end of this video, you will have complete understanding of how test bench works, both for learning purposes and also for real-time verification projects. Before we start learning about SystemVerilog Testbench, let's first understand an important question. What is the goal of verification? Why do we spend so much time and efforts verifying the designs that already written and seems to be working? So what is the goal of verification? If you answered finding bugs, you're only partially correct. So the main goal of verification is to make sure that the design behaves exactly as intended. So under all possible conditions before it's fabricated into hardware. So even though RTL design is written, compiles correctly, and that does not guarantee that it functions correctly. A small mistake in a logic, timing, or a corner case handling can cause the entire chip to fail once manufactured. So fixing that later can cost of millions of dollars. So verification makes sure that we have built the design right, not just that build something that runs. So when we design any digital circuit, for example, an adder, counter, or a processor, we first write RTL code using a SystemVerilog or Verilog. But just because the design is written and compiles correctly doesn't mean it will work correctly in every case. So that's why we do verification to check the design's correctness and reliability before fabrication. So the main goal of verification, first one is check functionality correctness. So the first goal is to make sure the design works exactly as per the specification, and whatever is written in the design document, the circuit must do the same thing. For example, if you take ALU should add, subtract, and multiply, then each operation must work correctly for all valid inputs. The second one, find the design bugs early. So another goal is to find the errors or bugs before the chip is made. So once the design goes for fabrication, it becomes very expensive and time consuming to fix any mistake. So this verification helps us find the bugs early in the simulation, saving both time and cost. So the next one is test all possible scenarios. So the design should work not only for normal inputs, but also for corner cases. So maximum values, minimum values, and overflow condition, sometimes unexpected inputs. So verification ensures that every possible case is tested thoroughly. And the next one, ensures specification compliance. The design must follow all the rules given in the specification or standard. For example, if you are verifying the communication protocol like AXI or UART, the DUT must strictly follow the protocol's timings and behavior. And the next one, measure coverage. So verification also check whether we have tested everything or missed something else. So we use coverage metrics like a code coverage, functional coverage, or assertion coverage to make sure all parts of the design and all scenarios are verified. And the last one, automation and reusability. So modern verification aims to make the test bench automated and reusable. So instead of writing manual test cases, so we use randomization, classes, and reusable environments like UVM to save the efforts for future project also. So verification gives us a confidence that our design will work perfectly in the real-time hardware. A test bench is a virtual testing environment that create a SystemVerilog or Verilog to verify, validate, and ensure that the DUT behaves correctly under all possible scenarios. So before it's synthesized or implemented on ware. So reusability is one more important aspect here. We can reuse the same test bench for multiple designs and also for configurations. So why this matters in the real world especially? So in the semiconductor industry, the verification consumes nearly 70% of the total design efforts. That's not a coincidence. That's a reflection of how critical it is. So go to the design circuits. So companies like Intel, Qualcomm, Samsung, Nvidia, and AMD rely on structured test benches built on methodologies like UVM to verify billions of transistors and working together flawlessly. So a single undetected bug at the chip level can cost millions of dollars in the respins and recall. So a well-built test bench is what stands between a successful product and a catastrophic failure. So some of these steps are automatically by the test bench, which other are controlled by you, the verification engineer. So how these steps are performed depends upon the methodology you choose, and like a basic SystemVerilog test bench or a UVM based environment. So now see the purpose of a test bench here. So to apply the stimulus to the DUT, so generate input signals like a data, clock, reset, etc. and mimics a real world operating conditions or test scenarios. And the second one is to capture and monitor responses. So observe the DUT's outputs in response to the applied inputs. And to check for correctness, compare DUT outputs with expected like golden results using the checkers or scoreboards, detect the functional errors and automatically. And to automate verification, reduce the manual checking by automating the test process and enables the regression testing, so running multiple tests automatically. And to measure coverage, ensure all the features, corner cases of the design are tested, helps verify completeness of testing. So to control simulation flow also, right? So start, restate, stop the simulation and manage the test sequences and randomize. Everything is done by in the control simulation flow. So to conclude, so test bench is a verification environment built around the DUT that drive the stimulus, monitors output and check the results against expected values using the scoreboards and checker, measure the functional coverage also. Everything is done automatically. So it removes manual efforts, catches functional bugs early and gives us complete confidence in the design before synthesis. So the key takeaway is that no matter how perfect your RTL design looks, it is the test bench that provides actually works. So without a robust test bench, verification is incomplete and your design is always at risk. So always invest time in building a strong, layered and coverage driven test bench, because that is what separate a gold, what we call a good verification engineer from a great one. So thanks for watching. So like, share and subscribe for more content. See you in the next video.